All right, and here's number 6 in our final example. Remember, the first thing we always do is factor. That'd be x plus 3 and x minus 3. And this will factor to be x minus 3 and x plus 2. Now, if you will notice, this is something new. We have not seen it to where you can x minus 3 and an x minus 3 will cancel out. That will leave me x plus 3 over x plus 2. However, I'm still sketching this function up here, which means I've got to deal with this whole function before it gets canceled out, okay? If something gets canceled top and bottom, that does not give me a horizontal or vertical asymptote. It doesn't give me a 0 on the graph. What it does is it makes a hole in the graph. I'll show you what I mean in just a moment. Let's go through everything else though, exactly the same. If I remember I've got to go put a hole in the graph, I can just sketch this and basically same problem, be done with it. Vertical asymptote comes from the bottom, so it's x equals -2. Zeros are the zeros from the top, that'd be -3, 0. Horizontal or oblique asymptotes, since the exponents are the same, you take the leading coefficients, that's going to be y equals 1. That's a horizontal. And then lastly, before we do the sign chart, the y-intercept, you put zeros everywhere there's an x. It leaves you -9 over -6, which is 3/2. So I'll do my sign chart. I'll incorporate all the things I just learned on the graph in just a moment. Now, my vertical asymptotes, my critical numbers are at -3 and -2. They're my vertical asymptotes and zeros. The one that cancel out, I'll take care of last. I just need to remember I got to do something with that, okay? So here's what we do. Pick a number bigger than -2, like a 0. We've already plugged it in and got it to be positive. And it will alternate because nothing's repeated on my critical numbers. So that's going to be the sign chart. Now let's incorporate everything we've put in here, okay? I know my vertical asymptote is at -2. I know my 0 is at -3. It's got a horizontal asymptote at 1. My y-intercept is at 3/2. That's right there, because it's a little bit bigger than 1. It's between 1 and 2. And now I'm going to put everything on here. The one thing I've got to watch out for, though, is this. What makes that, the things that canceled out, what would have made that 0? Well, it'd be a +3. That means over here at +3, I'm going to have a hole in my graph when I plug in the 3 right here. I'm going to plug in 3 into my cleaned up form, which is 3 plus 3 over 3 plus 2. That's 6 over 5. That means that when x is 3 at 6/5, which is just barely over that 1, there's a hole in the graph. That means the graph is going to come through here, almost touch that point, and then continue doing what it was doing, and it's just got a hole in the graph at the point 3 and 6/5. Between 0 and -2, it's supposed to be negative. Is that right? That's not right. That's supposed to be, if I do something, oh, sorry, this is all still in front of the -2. So that's supposed to go hug that asymptote. Between -2 and -3, it's negative. So it's going to go down like that, and then it's supposed to be positive, hugging that asymptote. There's my picture. The one new thing is, if something cancels, it puts a hole in the graph at that spot. That's called a point discontinuity. In other words, it's not continued through that point, but everywhere else it is, except for the vertical asymptote. Okay?